Now we're going to see how to use the Lagrange multiply method to find the optimized solutions. That's relatively easy if you understand that the Lagrange equation. So a few steps. The step 1, you always need to find the objective function. And the second one, we need to find the constraint. In reality, everything has a constraint. Every good solution is going to be a trade-off solution between the constraint and the objective. So in this particular example, we want to build a cylindrical tank. On the top is a hemisphere dome shape. On the bottom is a flat base. So this tank made by 3 pieces of surfaces. The top will be cost more, $20 per square feet. And the side, $8 per square feet. The bottom is the cheapest, $5 per square feet. But the constraint is you need to build these sides. The volume equals to 200 pi. So first, let's see our dimension. The dimension is uniquely determined by the height h and by the radius of the circle r. So let's look piece by piece. The bottom, let me call it S1. The area is pi r squared. And then the side is going to be 2 pi r, which is circumference, times h. We call it S2. And the third, the dome shape, that's S3. That will be 2 pi r squared, because the surface area of a sphere is 4 pi r squared. So you have your objective function as a cost function. You try to minimize. The cost function is $20 times the surface of the hemisphere, $8 times the surface area of the sides, and the cost of the bottom. Reduce a little bit, take out the pi r. This is what you have as your objective. And the volume equal the volume of the cylindrical circle, the cylinder, times the hemisphere volume, which is half of the volume of the ball times the base, which is pi r squared, times h, the height. This is the total volume, need to be 200 pi. So you got the G RH equals this, and the C equals this. We're going to use the Lagrange multiply method to solve it. So first, let's figure out the gradient. So the gradient to the V, you take a derivative to r first, then it's 2 pi r squared plus 2 pi rh. And then you take the derivative to h, that's a pi r squared. And then the gradient of V equals 2 pi r squared, 2 pi rh, pi r squared. So what about the gradient of C? If you take a derivative to r, that will be 90 r pi But this term plus 16 pi h. If you take the derivative to h, that will be 16 pi r. Well, the equation says this need to equals, no, the other way. Gradient of c need to equals lambda of gradient of v. You got that the equation says this equal lambda times this. And this equals lambda times this. Let's look. So we already got the two equations. This equal that. These are the two equations from the Lagrange method. Check it one more time. See, 16 pi r equal lambda times pi r squared. It's right here. Or we can do another way. Well, from the second equation, r must be positive. We cancel out r. We got the lambda equals to 16, r divided by 16. Pi cancelled out. Well, then you plug into the second equation, and you will find that the h. Well, we have the third equation. The volume, we plug in this, we find that the h can be write as R2. And then we plug h and r to the constraint gx equals 0. And then we're going to solve the r and the h. That's not too hard. It's just the substitution method. So the step 1, you get the r equal h, lambda equal r. And the step 2, you get the h right into r because you already know the lambda. And step 3, plug both the lambda and the h into the third equation, the gx y, the constraint equals 0, the volume equal to 200 pi. You're going to get the h and r. The interesting thing, even with this square root, the cube root, is the ratio between the height and the radius. It's always be 29/8. The second application is very interesting in the data mining and the statistics. There's a few concepts. First means what it means information entropy. The information entropy measure disorder of information. Means the bigger is the entropy, the less information you get. The smaller is the entropy, the more information you get from this distribution function. If I have n points, you can think about a dial with 6 numbers. 1, 2, 3, 4, 5, 6. An unbiased die. If you throw it, intuitively, you know each of them got 1 out of 6 probability. That's what our belief system, if it's unbiased. Well, how do we prove this? By using Shannon entropy equation. That Shannon entropy is used in all information science and the technology to measure how much information you had. And it's defined as the sigma of all this probability, Pj. Now the probability you adjust to each xj, we call it Pj. And for example, in this dias, if it's really unbiased, the Pj all equals 1 over 6 for j equal 1, 2, 3, 4, 5, 6. That's unbiased. But if you find that the die is not like this, over time, you might see somebody in the gambling is cheating. Well, the equation is simpler. Sigma j goes from 1 to n, depends how many points you're looking for, or you can put a pair of dice, and then if you have a pair of dice, you're going to have 7, 8, from 2 to 12, right? You have 12 different choices. So add all to the n, pj times logarithm pj of 2 bases. And that's the function to measure the entropy. So what is the constraint? The constraint is a probability. You add all the probability should be 100%. That's 1. So this G, you have this P1, P2, Pn equal 1. Okay, how many variables I'm dealing with? N. How big is n? Depends. If you consider one die, the n is 6. A pair of dice, the n could be 12. And that's what you have. Well, then you have 2 equations. The f is the probability function. I want to maximize the entropy. I want to be least biased probability. That means have the minimum information I know, just random. And then I have one constraint function g. So altogether, I get n variable right now at the Lagrange multiply. If you take the partial derivative, remember the similarity and the symmetric property, you just need to take the derivative to pk for the k equal 1, 2, all the way to n. And you get this. That's the logarithmic function. Oh, by the way, you might say, why you want to put a negative? The information is negative. No, it's positive. Because the probability is always less than 1. Since it's less than 1, the logarithm of pj is always negative, and the negative make it positive. The information is positive. Then you take the derivative of the f to pk, you get this. Take the constraint function to pk, you always get a 1. The constraint is just the p1 plus p2 plus pn equal 1. You take a derivative, of course, equal 1. And then the Lagrange method says this equal lambda times this. That's lambda times 1. What does that mean to you? That means doesn't matter what is the k. This pk of the logarithm for 2 always equals put it this way, negative lambda minus logarithm for 2. Doesn't matter what a k. So all this pk equals pj for any j and the k. So the conclusion is obvious. All this probability need to be the same. If they are the same and add to 1, and what does this mean? P1 equal P2 equal Pn, and the P1 plus P2, Pn equal 1, of course. All of them equal 1 over n. Just like the example I said, intuitively, the unbiased dice should always give you the equal chance when you roll it. So it's not a surprise finding, but just to show you, hey, this really shows you the Shannon entropy equation makes sense, because the result you find confirm your belief system.